Negative volume and negative area means there is intersection in the geometry. So there is no negative value. The coordinates can be negative, but the volume and surface should not be negative. Now I'll go to the model. In the energy, I will switch on the energy. Why? Because this is heat transfer analysis. So I have to switch on the energy. Then I'll go with viscosity. Viscosity, I'll keep it same. I'll not be changing K omega, a system model. Okay. Then materials. So all of them are water. So here you can say this. So remember, and let me just show you the bodies, number of bodies that it has. So it has 1, 2, 3, and 4. So this is made out of steel, outer body, steel body. Okay, this is outer body. Then this is the inner fluid or hot fluid. Then this is the copper tube through which the hot fluid is flowing. Then this is the cold fluid volume. So here, what do I need? I need copper, steel, and water. So I'll go to fluent database. I'll go with solid, steel, copy. Then I need copper. So where is copper? Copper, copy. Copy. Then I need fluids. In fluids, I'll go with water, liquid, copy. Okay. Now let me go to the cell zone condition. In the cell zone condition, I have only one heat exchanger. Okay. So there is one problem in here. So only it is detecting one body. So I have to go with different bodies. Okay. So I'll do that in the design manager. Let me just close this fluent. Okay. So I need to reopen it again. Okay, because some changes will be there. So let me just, so this is my cold fluid. Okay. Cold fluid, and this is fluid. Then this is my copper tube. This is solid. Then this is hot fluid. And this is outer covering. Okay, now let me update that. Let me update the geometry and let me mesh it again. Okay. So it is done. Okay. So it is done. Now let me update the same thing in Fluent also. So what I will do is I'll just delete this link. Then I will reset this one. Reset. So that everything is removed from the memory. Then I will update this one. Okay, update is done. Now let me open the setup. It's 6 process. Okay, the mesh transfer is done. I'll go with OK. So mesh transfer from the mesh to Fluent is done. It is successful. Let me go with check. Okay, check is also done correctly. Now I will go with, let me just check the cell zone conditions. Yes, now I have 4 cells. No problem. I'll go to the models again. Again, I'll switch on the energy. Okay. I'll not change the viscosity. I'll keep it that. Materials, let me add the materials again. So I will go with Fluent database. Then I'll go with solids. In solids, I'll select copper and I'll select steel. Copy. Then in the fluid, I will select water. Water liquid, copy. Then close and close. Now I'll go to the cell zone condition, the cold fluid, edit. So this is water liquid. Apply and close. Copper tube, edit. Copper tube is copper. Apply and close. So hot fluid, edit. Hot fluid is water. Apply and close. And outer covering is steel. Apply and close. Okay. So once it is done, I'll go to the boundary condition. Now in the boundary condition, I'll go with the inlet. So cold inlet. First, I will provide boundary condition to the cold inlet. To the cold inlet temperature, that means inlet temperature, it is cold, so I'll keep it. That is 280 Fahrenheit, 280 Kelvin. Okay. Or 290 Kelvin. Apply. And momentum, that is the flow speed. Flow speed will be a little bit fast. Flow speed is 5 or I'll go with 1 meter per second. Okay. Flow speed is 1 or 2 meter per second. Apply and close. Then hot inlet temperature is 400 Kelvin. And its flow speed is bit high, so 5 meter per second. Apply and close. And outlets, I don't have to provide any other thing. Outlets are all pressure outlets, so sinks, so there will be 0. Apply and close. Okay, apply and close. Now what I have to do is I have to go to my initialization. Let me initialize this model. Okay, initialization is done. There is a certain warning, but let's see whether this warning occurs or not. Every one-time step. Run calculation. Number of iterations I want to run is 200. Then calculate. Okay, so it will show me a graph of residuals. Residual means error. Remember, what is the stopping criteria for any simulation? When the error reaches a certain threshold, let's say I want for this simulation, I want a error threshold of 0.01. So when this threshold is reached, then you can say your simulation is done. It is very slow. Let me just check the total mesh that is created. It's a 3 lakh elements are there. Okay, hence it is slow. So what I will do is I'll just stop it. Okay. In the stop, what I will do is in the calculation activities, I will not save it. I will not save it. And in the initialization, I will initialize it again. And the run calculation, I'll go for 100 iterations because I want to solve it much faster. 100. Now calculate. Okay, it will take some time to solve. Lesson is done. Now let's visualize the results. So we'll go to our workbench and we will connect a result block. Now let me update the result. Okay, so I'll go for contour plots. sweep surface setup. So along z axis, so 0 and 1. Okay, so I will go with contours setup, and I will go with temperature. So I will see that for my okay. So you can see how the hot fluid, and I just have to see the hot fluid. Okay, not all. So I'll go with, I'll not display the walls also. Directly, I will go with wall copper tube. Okay, so the wall copper tube, it is showing me the temperature of the cold fluid. Okay, so when the cold fluid is entering, you can see it is to 90 degrees Celsius as I have provided, and it is exiting at nearly 345 degrees Celsius. Let me go with the other wall. Okay, so you can see in here, the cold fluid is entering. The copper tube, no? Okay, let me just display another thing. Okay, so you can see the cold fluid is entering at a temperature of 400 degrees Celsius, and it is exiting at a temperature of 345. Okay. So it is losing some of the temperature at the bends. So there is a problem in our result. Okay, the result viewer is not working correctly. But still we can get the same results in ANSYS Fluent also. Okay, got it. So this is the temperature distribution for the outer body, that is the cold fluid, and this is the temperature distribution. Let me just see. Temperature distribution for the hot fluid. Okay, this is the cold fluid again. Okay, hot fluid. Okay, clear. So this is how we can perform any type of CFD analysis in our software ANSYS Fluent. Also, we will cover, you can say, OpenFOAM. OpenFOAM is industry leading. ANSYS Fluent is also industry leading, but most of the simulations for research works in research domain, okay, are done in OpenFOAM.